So I'll need confirmation if everyone can see what is on my slide currently.
Yes, I can
Yes.
see it.
All right, thank you very much. As I have already been introduced by the moderator, my name is Hassan Abdul Wahab, and I am currently working as a system integration and deployment advisor at Chemonix International, which basically is an international development firm that basically oversees currently the implementation of global health supply chain um, um, project here in Nigeria. And as a system integration and deployment advisor, um, my role there is to come up with innovative digital solutions or ideas that could help improve the way in which current business operations happen within the organization. And when you talk about global health supply chain, particularly, it basically essentially is having the most effective way to distribute health commodities down to beneficiaries, most especially in rural areas that do not have access to some of these commodities or that cannot afford some of these commodities. And I feel like the problem we are solving is one that is deeply tied to logistics because we build solutions that enable um, the project to be able to effectively distribute these commodities to beneficiaries down there. And I think one thing that is notable to mention is that the experience of your customers um, with your business um, is highly dependent on your logistics. So whether your customers are satisfied with your services or whether they are satisfied with your product, I feel like that satisfaction is heavily dependent on the logistics of how that commodity or that service is being rendered to them. And for the purpose of this talk, we're going to look at how technology is revolutionizing the logistics and supply chain industry in order to create services that brings value and in order to facilitate the distribution of commodities to consumers. Now, I believe it is such a great time we are fortunate to be alive in right now because everywhere in the news, if you go on the internet, it's either one technology or another technology making waves. And I would say while we have just started harvesting the low hanging fruits of artificial intelligence at the current stage of progress, because we're currently in a quest for super intelligence, but with the advancement we've been able to make in machine learning, companies are able to get a lot of insights from data. They're able to recognize patterns from customer behaviors, and they're able to use this information to improve their logistics. And the supply chain industry is one that is not left out in this group of organizations that are or industries that are benefiting from advancements in technology. And like I earlier said before, that technology is gaining rapid adoption across industries as advancements in these different specializations of tech, such as AI, Internet of Things, quantum computing, electric, automobiles, robotics, and blockchain, they all seem to be paralleling each other and they seem to be contributing value to one another in one way or the other, such that the supply chain is becoming more robust, is becoming more tech agnostic and inclined in order to provide more value to customers. So I would like to just give a brief historical perspective on logistics and lessons we can learn. The origin of logistics are rooted in both and military operations and economic activities. And one of the most successful military strategy in combat is to target and destroy an enemy supply line while maintaining one's own, since an armed force without resources and transportation is defenseless. Take, for example, the story of Alexander the Great, king of ancient Greek kingdom of Macedonia, who is regarded as one of the greatest commanders in the history of time. One thing that he was notable for, because Alexander was able to conquer a vast majority of regions spanning from Greece all the way down to India, and he never suffered defeat in battle. One thing that was known about him is that he would meticulously plan for provisions, transportation, and supply depots before embarking on campaigns. And his armies would carry supplies for months at a time and rely both on prearranged and improvised supply lines. He was able to secure supply lines by controlling key cities and ports. So if you were to go to any region, conquer that region, he found a way to integrate that city or that region into his supply lines, thereby allowing him to depend less on homeland supplies, while leveraging the supplies from the territories which he had conquered. This allowed him to maintain a steady flow of resources from those conquered territories, and he was able to integrate local populations into his logistics strategy, such that those local populations were able to contribute to the success of his campaign. This allowed him to maintain momentum over a very long distance, of course, and we also have examples of where history showed us that logistical failures have also led to the defeat of some armies in battle. One classic example, as depicted in this picture, which we can see on the slide, is during the American War of Independence, which was between 1775 to 1783. The British supply system, they heavily relied on transatlantic shipments. And the problem with just transatlantic shipments was the fact that they were so slow, they were expensive, and they were vulnerable to disruption by American privateers and French navies. And so, as a result, the British, they struggled to maintain supply chains over the vast and hostile American terrain, and the local population um, would often resist British acquisitions, further straining their resources. That way, the British could not get the resources they need, they could not get the supplies they needed to carry on with the battle, and so as a result, they suffered a lot of defeat at the hands of the American army. So, why in business logistics or commercial logistics, the ultimate goal is not winning a battle, neither is it unleashing a deadly blow to enemy supply line. We can still, however, borrow valuable lessons and strategies from military logistics, such as strategic planning, efficient resource allocation, flexibility, and adaptability of logistic model to match the environment, as well as precise coordination. Those are some valuable lessons we can learn from those um, historical records. In logistics or in commercial modern day logistics, I think the focus right now is trying to get the right products at the right quantity, the right condition, the right place, the right time, to the right customer at the right cost. And these 7 hours of logistics, or which we also call the seven rights of logistics, are fundamental in any supply chain or any logistic operation, because you want to ensure the customers are getting the right product they place an order for, they're getting the right quantity they ask for. Because if any of these arrows were to become W's, which means if they were to become wrong, customers would be dissatisfied. And you can imagine the amount of effort or the level of effort it would take to employ reverse logistics to be able to get those products from the point of consumption back to the source or the origin, in order to rectify what the issue was with that product. And trust me, if such situations continue, you're bound to lose customer as a business. So in business logistics, we're trying to see that we get all of these 7 hours right when delivering or rendering services or delivering products to customers. Now, when we talk about logistics, there are things known as the functions of logistics, and there are a lot of them, but I feel like the most important ones that are the main functions of logistics are inventory management, warehousing, transportation, and last mile delivery. And if you think about it, logistics in its whole sense, it feels like an orchestra where you would have a conductor that is coordinating different sections of the orchestra that are responsible for playing different pieces of different variants of instruments. But the overall goal of that orchestra or the conductor is to get everyone to play in harmony in such a way that every aspect of the orchestra is contributing to the harmony that is expected to come from that music. And it feels the same way in logistics, because the role of the logistician is to ensure that every aspect of logistics are working in alignment with one another. And it becomes cumbersome when you think about the level of effort and the amount of tasks that needs to be accomplished to be able to coordinate logistical operations. And this is where technology comes into the picture to sort of create a way that these things can be accomplished effectively and efficiently in a way that drives costs down but increases value on the other end. And we're going to be looking at how technology is helping each of these different functions achieve their goal by going through them one after the other. I'll try to be as fast as possible so that we can keep to time. Now, when you talk about technology in inventory management is a function of logistics that oversees, controls, optimizes the storage and the flow of goods such that stock levels are adequate to meet consumer demands while avoiding overstocking and stock out. You don't want a situation whereby a customer places an order for an item on your mobile application or whatever medium or channel they are using to place an order for an item, and only to realize that after they've placed the order, they've made payments, they're getting a feedback that the item they have ordered for is out of stock. Now, technology comes in the mix here because we're trying to maintain optimal levels of inventory in such a way that when we're running low or short on inventory, we try to replenish those inventory in a timely fashion that allows us not to run out of stock or not to have too much stock in the warehouse in such a way that it ties down the company's resources, because that can be deadly for companies. And in order to maintain the optimal levels of inventory, it requires some level of effort and techniques such as inventory control, just-in-time strategy to ensure that as inventories are leaving, they are arriving at the time when they are needed. And things like economic order quantity, ABC analysis, where you're trying to categorize your items based on the most important ones in such a way that they are easy to access. So items which are more frequently purchased are categorized differently from items that are less frequently purchased. You talk about things like FIFO, LIFO, demand forecasting, vendor managed inventories, safety stock, reorder points, and all that. Now, all of these things, they feel a lot cumbersome for just one person to be able to coordinate, understand, and put together to enable the business to achieve its overall goal of getting commodity to the consumer at the right time. And these are just a few of some of the many techniques used to manage inventories, and a complex function like this present challenges at every turn. So variables like demand spike, for instance, which I have mentioned, once demand goes up, you probably want to have enough inventory levels such that you can meet with the changes in demand from customers. Now, with the adoption of artificial intelligence and machine learning, insights can be gotten from data for predictive analysis, and patterns in consumer demand can be easily identified, allowing for effective demand forecasting. Also, computer algorithms can implement some of the earlier mentioned techniques, performing accurate complex computations so that the level of human effort become very minimal, if at all any is required. With advancements in AI, with advancement in machine learning, we can gather data about our inventory, and with machine learning, we'll be able to generate models that are capable of predicting when there will be a need to reorder more stock, where there will be a need to replenish whatever is already running out of stock. And those are the opportunities that artificial intelligence and machine learning provide to us. With artificial intelligence, we get useful insights. With machine learning, we get predictive analysis that are helping companies even achieve things that are known as dynamic pricing models. So as the levels of demand go up, you want to adjust your price so that you can capture as much profit as you can from whatever commodity is out there. And these are some of the ways in which artificial intelligence and machine learning is helping with inventory management. Now, the Internet of Things is another useful technological innovation that is used in to optimize inventory management, as it allows smart sensors using barcode and radio frequency identification technology to take stock and track levels in real time. So imagine a warehouse where you want to keep track of your inventory, and one way to do that is to have sensors or to have devices that are positioned strategically at different places within the warehouse that are able to track when commodities are running out of stock, so that they can inform the system or provide insights to whoever is responsible for managing inventory that, this is time for us to acquire more stock, or this is time for us to take an action. And with technology, it's now possible to achieve just-in-time inventory such that shipments that are required to replace inventory as needed are procured in real time rather than stockpiling those products um, and tying down company resources. Um, so let us look at technology in warehousing as well. And one thing to mention is that you'll see that when we talk about these different functions, there's sometimes an overlap between these different functions. And this is where technology beautifully shines because it allows us to connect these different functions of logistics that would probably ideally be operating in silos in such a way that the whole form an holistic system in which data can be exchanged easily between each of the different components of the logistics system, allowing for greater visibility into the whole logistic operation. And warehousing is one of those functions that involves storage and management of goods and materials in facilities designed to facilitate efficient movement from the source of origin to the destination point. In warehouse logistics, one thing we want to do is to strategically place and organize goods within a facility in such a way that space is optimized and accessibility is easy, so that warehouse operations such as sorting, picking, packing, shipping can run smoothly with little or no human intervention. Warehouses also provide optimal storage conditions for perishable goods and materials. Hence, the need to have systems that detect when storage conditions fall below optimal levels for quick intervention are necessary. And one thing warehouses can also do is that they can act as consolidation points. So you can have shipments from multiple locations come in, but they are converging at a central location. And from that point, you can consolidate all of those goods onto one shipment in order to save cost. Another thing is cross-docking, which you're moving goods from inbound transportation to outbound transportation. Thereby, you're not wasting time in storing those goods. As the goods are arriving, you're shipping them out. Now, the different types of warehouses exist, ranging from private to public to cold storage and distribution centers. But one notable type that has been introduced by recent advancements in technology are known as smart warehouses, where you have a lot of technological infrastructures or devices or robots in those warehouses that are helping humans to quickly achieve tasks that would take a longer time for humans to be able to achieve by themselves. But with these robots, we're able to achieve complex tasks, we're able to automate repetitive tasks so that humans can focus on more strategic tasks. I've mentioned on barcode and RFID technologies, which are just basically technological tools that can be used to track products as they come and as they leave the warehouse. And these are tools that are helping to shape the landscape in logistics and supply chain. When we talk about the functions of logistics, one of the major ones to talk about is transportation. And transportation is one major function of logistics, and enabling the movement of goods and materials from one location to another location. And the goal of transportation is in logistics to ensure that goods are transported efficiently, cost effectively, and on time. Now, there's one problem that is a mathematical problem or a computer science problem, but generally it can be categorized as an optimization problem in mathematics and computer science, which also has application in logistics, and that is known as the traveling salesman problem. So the traveling salesman problem poses a question that given a number of cities and the distances between each of those cities as depicted by the map on the right, and given the numbers of cities and the distances between those cities, what is the optimal route that a traveling salesman should follow in order to be able to visit each of those cities once and return to the city of origin? Now, this is an optimization problem and it's very applicable in logistics, because when you have deliveries to make across multiple locations and you're using whatever vehicles you're using to carry out those deliveries, you want to ensure that the route which those vehicles are following is the most optimal route possible, such that fuel consumption is low and commodities reach customers or products reach customers in the fastest time and the shortest time possible. And this is an area where quantum computing has the potential to change the way things are happening, because when you talk about optimization problems in computer science, these are complex problems that have been categorized as NP-hard problems, because basically these problems do not have an efficient algorithm, or they do not have a perfect solution that solves them because of the complexity, the many variables that are involved in problems like this. But when we come to quantum computing, we might not be able to get perfect solution, but we are able to get near optimal solutions that are able to help us at least achieve the closest um, optimal solution when talking about route optimization in logistics, so that we can save costs and reduce fuel consumption while carrying out deliveries with vehicles. Now, there are route optimization software tools like
Not
Google
to
Maps.
not to interrupt you, Mr. Hassan.
Okay,
You have 2 more minutes.
all right,
Thank you.
fine. So, route optimization software tools like Google Map API and specialized logistics software, they reduce delivery times and fuel consumption, like I earlier mentioned. And there's something called telematics and GPS tracking, another set of tools that are a game changer. This telematics essentially collect information from vehicles. They are mounted on vehicles and they're able to collect information from vehicles like the condition of the vehicle, the speed of the vehicle, and this can provide insight to managers or supervisors that are supervising trucks that are out there doing their duty to ensure that the process are going accordingly as they should, and if there are need for fixes or if there are needs to identify faults on the spot with vehicles, this information can be captured in real time. And this is also another area where Internet of Things plays a role, because with Internet of Things you can connect multiple devices together and create a central database where those data can be collected, they can be processed, and then they can provide insights by streaming those data to perhaps logistics softwares that managers or top leadership can have access to give them insight into how well their logistic process is doing. So I'll just quickly wrap this up so that I don't eat into more of our time. Um, but lastly, one thing to mention is technology in delivery, last mile solution. Emerging technologies such as self-driving and drone deliveries are revolutionizing last mile delivery and improving customer experience in the process. You now have autonomous vehicles that leverage technologies like AI sensor, cameras, and GPS to navigate routes in transportation network in order to deliver packages to customers' doorsteps. And this is very important, and this is a very innovative solution. Even though it is more common in urban areas with dense population, it is helping to solve a lot of challenges and reducing the time in which we get products delivered to customers. Lastly, and I'm going to close it out here, is blockchain. Blockchain is an heavily discussed topic in logistics and one that cannot be left out when we talk about logistics. And the essence of blockchain is that it creates transparency. It creates a tamper-proof ledger of transactions whereby you can enter transactions into the blockchain to track every step along the supply chain, to be able to track from where the goods are originating from to their eventual destination, and any process along the way can be easily tracked. And on blockchain, you can run smart contracts, which essentially would execute based on the fact that specified conditions are met. Blockchain is a very elaborate topic to discuss on logistics, but one thing to note is that it allows for transparency, visibility, tamper-proof ledger transactions that cannot be altered or that cannot be modified without consensus from the whole blockchain system. Now, the future of logistics, this is where I'm going to close it out. I think in the future, we're going to see more of AI adoption in logistics. We're going to see more of blockchain incorporation in logistics. We're going to see a lot of green logistics, the concept of green logistics, in which we are trying to reduce carbon emission to as low as possible by using electric or hydrogen powered vehicles. And I also think in the long run, there's a possibility that logistics will extend just beyond transportation within Earth. It will even go as far as interplanetary operations, where recently in the news we hear about colonization of Mars and how technology is rapidly evolving in such a way that we want to get humans to be interplanetary species such that they can colonize Mars. And you can imagine that there is a window of opportunity for logistics to be able to serve that industry as well by getting products from Earth to Mars and back and forth. So with that, I'm going to wrap it up by saying thank you for listening to this presentation. I feel like I rushed it, but I think we all kind of like understand that we have a constraint with time. But I hope that during the discussion section we'll be able to ask more questions and talk more on this topic. So thank you very much, everyone.
Thank you so very much, Mr. Abdul Wahab. There is a saying, follow who know road. I always thought I know a bit about statistics, but after your presentation, I know I just have to go and go back to my books in order to know more and more. Thank you so very much for the wonderful presentation, and I know the audience are very much happy to hear some of the things that you just mentioned, which to some of us are first time. We are first time hearing things like that. Thank you once again, and we are happy to have you today.